Welcome back, everybody. Literally, because we just ended the other video like 10 minutes ago. I had to use. Yeah, I had the same shirt on. Don't worry, it's not a different day. It's the same day. It's actually the same hour. But I had to check my portfolio to see how much money I just lost, and then I had to go to the bathroom, and then I had some candy. Math. Welcome to Modern Ed. Well, 10 minutes ago, we just finished up the product property. And now we're on the quotient property. And chances are you're also probably watching these 10 minutes together because you probably have a test tomorrow and you're trying to speed run through these videos and cram all the information down in one night. And for that we say, check the timestamps. All the information's there. So the quotient property, very similar to the product property or the multiplication property. Basically what you're doing is you are combining the operation with both of the radicands underneath one radical. So that means is that if you have the root of some number divided by the root of another number, you can write it just like that. But the opposite is also true, where if you have the root of two numbers being divided like that, you can actually split them up in that direction as well. So how does that actually look? Well, if I just had the root of 20 all over the root of 5, I could write that as the root of 20 divided by 5. That's going to give me the root of 4. And since I know this is my square root, and I'm at the square root of 2 times 2, I have two 2's. It matches my index. I'm going to have 1, 2, boom. Because if you actually took the root of 20, the root of 5, you'd actually get some kind of weird stuff because, you depending on how you calculate it, you might run into irrational numbers or something like that. But if you just take the root of one number divided by the other number, you can actually simplify it down and get a pretty easy answer. The one that your teacher's looking for in your test tomorrow. So whenever you are dividing, you might run into some problems where you have to use the conjugate. So what the conjugate is it's basically used to get rid of radicals in the denominator. Basically, it allows you to rewrite the denominator as like a different expression, but not a different value. So that way there's no denominators in it. And it's going to have the same exact numbers. It's just the opposite sign in the middle. So what that actually looks like is, let's say we had something that looked like the root of some number A plus the root of some number B. So we have a binomial expression here. The conjugate is just going to be the same numbers, but a different sign, the root of B. So even if it's more complicated, and we had negative 14 times the cubic root of x squared minus 7 root of y, the conjugate, again, is the same exact numbers and values, just a different operation. I'm sorry, the opposite operation. So addition becomes subtraction, subtraction becomes addition. That's what the conjugate is. So hold that in the back of your head because in some of our problems that we're going over, you'll see that come up. So let's take a look at one of our easy problems. So here we have the root of 5 all over 5 times the root of 80. So let's use the property that we just went over. So in this case, I'm going to write this as 1/5 times the root of 5 over 80. Because remember, technically there's a 1 in front of here, and these would be our coefficients, and these would be our, expression over here, the root of 5 over 80. So now what I can do is rewrite this as that. I know that 5 and 80, I'm going to have, let's see, 80 divided by 5, that would give me 16. So I know that I have the root of 1 over 16. All right? And now we actually want to rearrange this in the other direction that I mentioned earlier, because it'll actually help us write this as the root of 1 all over the root of 16. Because in that way, we would have 1/5. The root of 1 is just 1. The root of 16 is 4. That's going to give me 1 over 20. Okay, so now let's take a look at a median problem. So this is where we're going to have to use the conjugate. The reason we know that is because down here in the denominator, we have a binomial, meaning a two-term expression, one term, two term, and we have an operation here, plus. So what I'll go ahead and do is write, that's my highlighter. I'll write 2 all over negative 3 plus root 3. And whenever you want to get rid of this radical in the denominator, because in the most simplified form, in the most correct form, you typically don't want any radicals in the denominator. Reason being is that you don't want any irrational numbers in your denominator. It typically just makes it easier to put those up on top. Although in my humble opinion, it's a little bit outdated because calculators can compute it no matter what, but I don't know, maybe math curriculums just haven't caught up to it yet, to be quite honest with you. It's totally superfluous. Yeah, but it is what it is. So I'll teach you how to do it anyways. Subscribe, and we'll go over the top 5 things that are the most useless that you'll learn in math. So anyways, to get rid of this thing, you multiply by the conjugate in both the numerator and the denominator. So the conjugate would just be the same exact numbers, different operation, just like before. And you put that in the numerator and the denominator. Reason being is that, remember, if you have the same exact value in the numerator and the denominator, you are dividing something by itself, meaning that it equals 1. Anything divided by itself is 1. So what this ends up happening is that when you multiply these numerators and these denominators together, you are changing how this expression looks. But since you are technically multiplying by 1, you're not actually changing the value. And that is something I say to my students all the time. You're not changing the value, you're changing how it looks. Because remember, you're multiplying by 1 technically. So what we're going to do now is we're going to multiply the numerators together. So we'll have negative 3 minus root 3. And then we're going to multiply the denominator together, and you'll see why we're doing this in just a second. But we're going to have negative 3 plus the root of 3 times negative 3 minus the root of 3. Okay, so now let's either FOIL or distribute these to make this as simplified down as possible. So 2 times negative 3, that's negative 6, minus 2 root 3, all over, and now we're going to FOIL this. So my FOIL is first, outside, inside, last. So I'll have negative 3 times negative 3, that's a positive 9. Negative 3 times a negative root 3, that's plus 3 times root 3. Then I'll have root 3 times negative 3, so that's negative 3 root 3. Then I'll have minus root of 3 times 3. And remember this, anywho, now that we have this, we're going to simplify this down even more. So I'll have negative 6 minus 2 root 3 all over. So 9 is my only whole number down here. So I'll leave it there. Now I have a plus 3 root 3 and a negative 3 root 3. So this is going to cancel because you're subtracting something from itself. So anything subtracted from itself is 0 by definition. And I'm left with a minus 3. Why a minus 3? Because again, this is the square root. I have 2 3's. It matches my index. I'm going to pull one of them out. So that's actually why we do this, because if you think about what it looks like now, this is a lot nicer than this up here. And the reason why we multiply by the conjugate is because what ends up happening is that when these two have different signs, but they have the same exact values over here, there's a property that you may or may not have gone over in class. But what you end up with is a squared minus b squared. Basically, it gets rid of the radicals, it gets rid of any irrational numbers, and you now have a much nicer denominator. But in this case, we can still simplify down a little bit more because 2 is a factor of 6, and 6 is a factor of 6. So now I can actually simplify this down a little bit more. If I'm dividing each thing by 2, I'm going to have a negative 3 minus root 3 all over 3. And there you have it. That is that simplified as much as possible. Okay. So now let's head into our much more difficult problem. Okay. So this one's going to require a lot of writing, but it's still going to follow the same exact steps. So I have 5 square root of 2x to the 4th plus 4x all over 4 plus the square root of 3x to the 4th. Basically, this is the same exact thing as our last problem. We still have to multiply by the conjugate, and we know that because, again, we have a binomial, a 2-term expression, one term here, the other term here, with an addition operation. So we're going to multiply by the same exact numbers, but with the opposite operation. So what that's going to look like is we will have 5 times the root of 2x to the 4th plus 4x all over 4 plus the root of 3x to the 4th. And again, multiplying by the conjugate, same numbers, different sign. Okay. So now, just like before, we're going to multiply the numerators and the denominators together. And so it might look pretty intimidating, but again, if you take it step by step and make sure to not make any mistakes, you'll get the right answer every time. So let us do just that. So it might help you you can go ahead and FOIL each of these right away, or you can do another step of math and write them, whatever helps you in your organization method. I personally would write these out again, just to make sure I know exactly what I'm working with. I would have 5 the root of 2x to the 4th plus 4x like that times 4 minus cubic root 3x to the 4th all over 4 plus the root of 3x to the 4th times 4 minus the root of 3x to the 4th. Okay, so now I can start foiling this. Let me multiply 5 square root of 2x to the 4th with 4. So I'm just going to have, multiply this together. So I'll have 20 times the root of 2x to the 4th. That's just my coefficients. Then for this one, I'm actually going to keep this written out for now, like this, and you'll see why in a second. 3x to the 4th. Okay, then I'll add 16x, and then I'll subtract 4x times the root of 3x to the 4th. Okay, so if anything was under the radical, I put it all under 1, and if the coefficients, I multiply them together on the outside. And that's going to be divided by, let's see here, 4 times 4 is 16. Again, foiling first, my outside minus 4 root 3x to the 4th plus 3x to the 4th, the square root of that with 4, plus 4, 3x to the 4th. And then I'll have minus the root of 3x to the 4th times 3x to the 4th. I'm not going to combine that just yet, and I'll show you why. Because if I leave it like this, remember that each of these is a square root. So what I'm looking for are 2 terms inside the radical, or the, to be the radicand, so that way I can take one out. And again, if that does not sound familiar to you, we have a video on that you can see in the top right corner of your screen. Okay, so I have a 20 here. I know that I have the root of 2, and I know that x to the 4th can be split up just like that. X squared and x squared. Because remember, when we have the same exact base and we have exponents, we put them together with the same base, but we add the exponents together. So in the opposite direction, x to the 4th would just be 2 different sets of x squared. And let me subtract from that 5 times the root of, I'm going to keep this the same, plus 16x minus 4x. And over here I have the same thing. I can split up that. Man, my handwriting is messy. Okay, 16 is my only whole number, so I'll keep that in here. And just like our last problem, you'll notice that this is a negative 4 root 3x to the 4th, but we have the same term, opposite sign. So that's going to go to 0. We don't even need to write that. That's exactly why we did the conjugate. And what am I going to subtract? Well, here I have 3x to the 4th and 3x to the 4th. I have 2 identical terms underneath the radical, which means I can pull one of them out. Which means I'm going to subtract 1 3x to the 4th. So now let's simplify this top part. So I would have 20. I have 2x squareds, so one of them comes out. 2 is going to stay there because I can't simplify that any further. Minus 5. I have 2 sets of x to the 4th, so one of those is going to come out. But 2 and 3, I can't simplify those anymore, so that's going to leave me with 6. Then I'm going to have 16x here. Minus 4x. Well, you know what? I have an x squared that can come out. Just like that. And let me just go ahead and save myself some time and write that as x cubed, because I had an x, 1x squared to come out, x cubed. And I'm left with root 3 all over 16 minus 3x to the 4th. That is a lot, but if you look through it step by step, I can see that I have 16 minus 3x squared. It's not going to go anywhere near that. So I am actually done right now. This is simple that I can make it by hand. And there you have it. So even though this might look a lot more disgusting, for lack of a better term, than other problems, if you follow the same exact steps each and every way, you will make sure that you get to the right answer every time. Hit that like and subscribe button. Let us know if you have any questions. And take it easy. I'll see you in 10 minutes. Is that more organic for you? All right. 10 minutes ago, we worked on the